So let's come back to, let's push our progress a little bit more, and then I'll let TA to take over for introducing our third hands-on. And before that, let me clarify one thing. I think here's a typo in this slide. Actually, this one should be the next request because this one, bi.next is about to point to the next BIO. So it should be point to the next request. Okay, so and this bi-io-vector, this pointer will point to the bio-vector. And bio-vector means one operations. Okay, and one operation means to access the continuous data in the systems, just like in the patch. Okay, so here is a request, not the IO. Sorry, not the IO operations. Okay. Okay. So there are also some concepts for like soft links and hard links. I think it's quite interesting, so I just put it here. So soft links, just like the shortcut, just like in your no matter in your Windows or Linux, actually there is a shortcut concept. And soft link is about a separate file contains a path or reference to the target file. So this is only about the reference, not really get the new file. So you can think about like this. So this is our indexing for the files. So like the file.txt. And if we are going to create a shortcut or a soft link for this file.txt, so it will like this. This is a soft link for this file. And actually, because this is a shortcut, so this is also another file. So it will get another idle number here. But the thing is about actually the idle number will point to a very spatial data block. They will point back to here. Okay, so actually this file.txt, this reference can help to reference back to file.txt, and then we'll go through the same path. The file.txt will find the idle number, and idle number will point to the data blocks on the storage device. Okay, so this is the reason why when you double click on the shortcut, actually you can still access the original data because the shortcut will redirect back to the original data. Okay, and then if you delete this shortcut, actually the original file will not be deleted, right? But if you delete the original file, then the shortcut will be missing. I mean, it cannot link back. So this is the reason here. And in addition to soft link, there's another concept called hard links. So hard links means the file shares all the attributes of the original file. Because in soft link, actually, we only create a dummy file or like a reference file. So it doesn't really point to the data blocks or like the real data. And for hard links, it is about they share the same inode. So no matter the original file or the hard link files, they share the same inode. So they can point to the data blocks. Okay, so the reason for using this kind of hard links is about sometimes when you are going to back up the data, and in this case, you can use a hard links to back up the data. Otherwise, if you use a soft link, it is not really a backup because using a soft link, if you misdelete the original file, then the reference or like the soft link cannot get back to the original data. But using a hard link, actually, how many hard links with the original file you will have a counter to keep track of these kind of numbers. For example, if you have one original file and one hard link, then the counter will be 2. So if you misdeleted the original file or delete the hard link, the data blocks will not be deleted because the counter will just drop from like 2 to 1. And the counter goes to 0 will trigger the delete operation here. Okay. So this is about like soft link and hard link. And in Linux, actually, you can try on your Linux to use this kind of soft link and hard link command line to try it. Okay. So, oh, this is not recall, sorry. So this is the layout concept of the file systems. And then I think this is quite interesting for you guys to know. And this is also very important. So file system, just like it is going to describe the data stored on the storage device. Okay, so we use an example is if this is a storage device and the physical layout of the file system on the disk is like, one moment. Okay, before talking about this, let's first give you some assumption. If there is a directory tree like this, there is one subdirectory 0, and then under the subdirectory 0, there is file 1 and file 2. And another directory is subdirectory 1, there is file 3. And then we have one file is in the same directory with the subdirectory 0 and directory 1. So as we mentioned, let's first move on to look at this inode part. So for the inode part, actually, for each directory and each file, they have their own inode. So you can see that each one, they have their own inode. Okay, and the difference is about if this is a file or if this is a directory. So if this is a directory, then we will get the directory entry. And for the file, there is no, the shared directory entry. So what do I mean? Like this. If we're going to store this kind of structure on the storage device, first of all, in the storage device, in the very beginning of storage device, there are two blocks. One is called boot blocks and another is called super blocks. So boot blocks is when we are going to boot your system, then system will read out CPU will read out the operating system from the boot block to boot your systems. Okay. And then a super block is about, because for each disk, you can have your own file systems. So this super block is going to describe which kind of file system you are using and what kind of rules you are going to follow. So super block is just like for this disk, maybe you are going to partition to, for example, ext3, for example. Then this super block is ext3 super block. Okay. But also in this storage device, actually, it is possible to partition into two disk partition, and then you give different file systems. Okay, so on the same disk, it is also possible to have more file system on the one disk. Okay, this is just a kind of interesting to let you know. And after the super blocks, actually there are a lot of slots you can think about, just like the inode table. So this inode table is going to point to the data block or the directory block. Okay, so after the inode table, there is an area called root directory. So the root directory start here, and then, for example, file 1's content, they will be stored in data block. So there are two kind of data blocks. One is for file data, and the other is for the directory data block. Okay, so for file data, it's just like the content for file 1 will be stored in this data block. Okay, so when you are going to access the file, the data belonging to file 1, you need to first check the inode table and then to find where is the data block. And then the file inode table will return you, okay, file 1 is stored on which kind of location. And you can start to read out like file 1, for example. Okay, but how about this subdirectory 0? Because this is a directory. And we say actually directory in Linux it looks the same as the file. So actually it looks like this. Oh, I think this is not important. Let's skip it, come back later for this one. Okay, so actually for directory, it is also the data block will become a directory block. Okay, so inside the directory block, there are several directory entries inside, because this one is subdirectory 0. So inside subdirectory 0, there are two files, right? So for these directory blocks, we maintain the directory entries correlated to this directory. So for example, because we store these two files, then for the directory entries, there will be two entries. The first one is to let us know what is the inode number for the first file. So because file 1 here, the inode for file 1 here is 4. And then the inode for file 2 here will be 5. So in this example, inside the directory entries, the first directory entry will go for inode 4, and it also maintains what is the file name for this file. Okay, and also for inode 5, it is belonging to file 2, and it also will store the file name for this inode. Okay, so one interesting to let you know is actually the file name is not stored inside the inode. In Linux, the file name is stored inside directory entries. Okay, and the reason is about because the inode here, they have the same size, but because file name, usually you can have different name for the file name, right? So if we store the file name inside the inode, then the inode table will be hard to maintain because there will be variable size for the inode table. Okay, so in Linux, their decision is to move the file name into the directory entries. Okay, so this is about the data blocks and directory blocks. And I think there is actually this figure is, I just get this figure on the internet, and there is some error here because here they said for this one, for this sub directory 0 here, they're saying like, hey, actually this is the D entry 0, but actually this is not the D entry 0. It is the directory. Okay, and what is the entry we will introduce next time, because the entry will be related to the virtual file system structure. Okay, so I think maybe we can first go for the third assignments, and then if we have sometimes we can move on to the following content. Okay.